So with curve fitting with linear models, we're going to fit scatter plot data using linear models, and we're going to basically just do it with technology, but we're going to actually plot scatter plots, and then we're going to find what's called the line of best fit and put that on our graphs and use that line to answer questions. All right? So researchers such as anthropologists are often interested in how two measurements are related. The statistical study of the relationship between variables is called regression. Scatter plot is helpful in understanding the form, direction, and strength of the relationship between two variables. Correlation is the strength and direction of the linear relationship between two variables. So a positive correlation, all right, is actually going to be a situation where your scatter plot has a positive slope. A negative correlation, it would have a negative slope. And like in this third one here, when you've got data points all over the place, then there is basically no correlation there. So if the slope of your data is positive, then you have a positive correlation, and we'll talk about more specifically about that. And if it's negative, it has a negative correlation. And if it's just all over the place, there's nothing. Right? With correlations, they are similar to slope in that with the positive and the negative, but when you're talking about correlation, the most a correlation could be is positive 1, or the lowest it could be would be negative 1. And that would be perfect. That would mean that every line or every point is exactly in a perfect line. Right? So when you have a normal linear model with the points that fit on it perfectly, you would have a perfect correlation of 1 or negative 1, depending on whether it's positive or negative slope. Right? If there's a strong linear relationship between two variables, then a line of best fit or a line that best fits the data can be used to make predictions. And so what we're going to do is that we're going to, first of all, we're going to make scatter plots by hand, and then I'm going to show you how to make them with your calculator and how to find the line of best fit with your calculator. All right, so which is, we're going to call it, it's called linear regression. And so we're going to do that. All right, so right here we have Albany, New York, and Sydney, Australia, about the same distance from the equator. I want us to make a scatter plot with Albany's temperatures as the independent variable. Name the type of correlation, so we're going to tell whether it's positive or negative. And then we're actually going to find the line of best fit and find the, we're going to graph it and find its equation. Right? So, first thing I want you to do is we're going to make a scatter plot of this data. Right? With Albany's temperatures are going to be the independent variable. So let's see if I can do it. Good, it's going to pull it behind. All right. So we need to draw a graph. So they're all positive, so we just need the first quadrant. And we're going to go ahead and plot those points. So I have from a 1 to 10, I'm actually going to change these so that they go from 0 to 100 on both the x and the y. All right, going by 10. So we have 100. What did you do? Oh. Okay, so 0 to 100 on the x, 0 to 100 on the y, and then we're going to plot those points. All right, so there's our scatter plot. All right, so what kind of correlation does this have? Is it positive or negative? Sabrina, positive or negative? Okay, negative, because the slope is negative, the correlation is going to be negative, all right? So this has a negative correlation. All right? Okay. Now, to be able to do this with our calculator, right, we have to put the data in the calculator. So we're going to put the data in our lists. All right? So to get to the lists, all right, so we're going to put data in list 1, list 2. We're going to put Albany in list 1 and Sydney in list 2. So to get to your list, you go to Stat and Edit. All right, so Stat and Edit. All right, so make sure your lists are clear. All right, so hit clear and enter when you're at the top. All right, to delete them, any of the lists you have. All right, and so go ahead and put Albany in list 1 and Sydney in list 2. So always when you put them in, make sure you double check them to make sure that they are correct, right? Because one little mistake on one number can cause a lot of issues for you. So it's always good to double check them, all right? Now we're going to make a scatter plot on our calculator, all right? So to make the scatter plot, all right, so we want to turn it on first of all, so we go to second y equals. So second y equals goes to our plots, and we want to make this a scatter plot. So first of all, we're going to turn it on. All right, so make sure that on is highlighted. And then we want the first one is the scatter plot. All right, and then probably your list, your data are in list 1, list 2. All right, it probably says list 1 and list 2 here then. All right, and then I always use the square for my types of dots. You can use a square, a little cross, big dot, or little dot. All right, and then if we're using color ones, you can change the color. All right. Now, once that's turned on, then so that our calculator will actually make a window so it fits the data, right? And if you press Zoom and Stat, which is Zoom 9, it will make a window that fits that data for you, all right? And so it actually shrinks it up, right? So if I look at window here, then it's going to be just big enough for that data. So we can see that it's going from 27 to 74 on the X, 42 to 70 on the Y, because that's all I really need. All right, we could have done that on our calculator or on our paper too, but we did the whole thing. All right, so now if I press graph, all right, so it's there. So we've got our graph there. Okay, here's our scatter plot. Looks like what we have on our paper, right? Except our paper is a little bit more condensed, right? Closer together. So, all right, we put the data in our list, turn our scatter plot on, do Zoom 9 so that it fits the window. All right, so to find the best fit line, all right, we go back to Stat, hit the Stat button, go over to Calc, all right, and then we're going to do linear regression, AX plus B. All right, so Stat, over to Calc, and number 4, linear regression, AX plus B. Now you could do 8 also, which is A plus BX, but we always do number 4. All right. Now, you need to make sure that it says list 1 for your X list, list 2 for your Y list. All right. And then we're going to go down here to where it says regression, store this regression equation. All right. And we want to put that in Y1 so that it goes right into our Y equals. Now we don't have to, we could write down the numbers and put them in there, but it's easier if you have it going in there. So where it says store regression equation, we're going to put Y1 there. All right, so if you go to alpha trace, all right, there's all of our Y equals. So we could put it in any one of the Y equals we want, but we're just going to put it in Y1. All right, so you should have X This should be list 1, y list 2, and regression, store regression equation y1, right? Right? So then we calculate. All right. Now, make sure of a couple things, right? So your A is negative 0.4638, right? Everybody got that? Okay. B is 80.08, right? So A is your slope, B is our y-intercept, okay, for our line. Okay. Now, does anybody not have these R numbers? Okay. All right, so we'll go to mode, right, because I want those on, right? Go to mode, and where it says down here, stat diagnostics on, you might have to go to scroll down to page 2. You want that to say on instead of off. Okay, we want the stat diagnostics on. Okay, and then just hit enter when you clear out of there, and it'll bring it back up. Okay. All right. Now, what this tells you, okay, R is the correlation coefficient. All right, it's the number. Okay, we talk about correlation. We say that it's positive or negative, but our R here tells us what's called the correlation coefficient, and it tells us how good of a fit our line is to our data. And the closer this number is to positive 1 or negative 1, the better the fit is. So since with this being negative 0.98, that's pretty close to negative 1, so we know that our line is a really good fit. All right. So if you go to graph now, then you should see the line on your. All right. So we need to draw this line on our paper now. Okay. Well, we know two things. We do know that our slope is 0.46. Our y-intercept is 80. Okay, well that's fine, but that doesn't help me a whole lot. All right. So there is an easier way to do it. So hit trace. All right. And first thing it says is the plot. All right. So then you have to go up arrow or down arrow to get onto the line. All right. And so we need 2 points to be able to draw our line, right? Okay. So we could just draw it so it goes between them. All right. And here it looks like this line goes through that point there, which was at, what was our third highest X, which was 67. All right, so so if I hit 67 here, all right, should put me right at that point, right, 49. Okay. So we're going to draw our line through that point there, and our y-intercept was at 80. So if I go to my graph, okay, and I have a y-intercept of about 80, right, and I want to go through that point then. Right. So the y-intercept is 80, and I want to go through that point 67, what was it, 67.49. All right, so to be able to make these scatter plots, find the line of best fit. All right, using our calculator. Put the data in our list, list 1 and list 2. We make sure our scatter plot's on, all right, which once you turn it on, it's on. All right, so for the next one, it's already on, and all we'll have to do is redo zoom 9 to get to work. And all right. And then to find our line of best fit, we go to stat calc and linear regression, AX plus B. So make sure you've got these steps down. All right. If you can memorize them in your head, great. If you need to write them down, take a moment and write them down. All right. Now the last thing we need to do is we need to write the equation of the line. All right. So here we've got y equals, and let me go back to it just for a second. So it's actually here now, in our y equals. All right, in y1, we now have our line there. Okay, so we'll do negative 0.464, let's do 3 decimal places, 0.464, and if I scroll over, it'll take me to the y-intercept in this case. Then. All right, and it was 80.08. Okay, so we have y equals 0.464x plus 80.08. So there's our line of best fit for that set of data. All right. So with this basketball question, we've got a positive correlation. All right, so we got our data in a list. Now, if once you do this, the one thing you got to remember to do is, I had an equation in my y equals. I want to make sure I get rid of that. Okay, all right. And then here's my zoom 9. So here's what your graph should look like then, which looks very similar to the one we drew. All right. And so to find the equation, the best fit line, stat, over to calc again, and number 4. And I actually changed mine. I'm using lists 3 and 4 right now, so I can save that data for later. And so if you use different lists, which you can use, all right? My X list is now list 3, my Y list is list 4. The numbers 3 and 4 you've got in blue on your calculator above the 1 through 6 is L1 through L6. Still going to store this in Y1, so alpha trace. And calculate it. All right, so here's my numbers. So this isn't quite as good of a fit as the last one we did because the correlation coefficient R in this case is 0.885, where the other one's 0.98. All right, so if we look at our graph, here's what our graph looks like then. All right, and we can see that my line goes through right through 3 of these points. So when I draw that best fit line, then I just want to make sure that it goes through those 3 points. All right, to draw it correctly. All right. So when I write my equation, we've got y equals 0.775x minus 5.8. Right. So we've got to graph it. So put it on our paper. Right. So that we can actually draw this line through here. So it looks like it's that line there. Right. All right, so let's do one other one together. All right. Okay, so we're going to do this one here, this meteorology application. Now, we're not going to do the scatter plot on paper for this one, okay? Right now, we're just going to utilize our calculator for this so we get through and answer these questions that they have. They have a couple questions they want us to answer, or one question they want us to answer with it. All right, so use this data. And we're just going to do it on our calculator, okay? So you don't need to plot this on your paper. We're not going to draw the line of best fit on our paper right tomorrow. I just want us to be able to get to the point where we can find this answer down here. So for this one then, we're just plotting it on our calculator, all right? So I changed mine again. Now I want to show you something also that you have to be careful of when you're doing this now. That is that you'll notice that now I have two graphs on my calculator, okay? That when I go to my y equals, you can see now these things that are highlighted, they're highlighted, the plots are highlighted because I turned them on, right? And I can turn them on and turn them off just on my y equals, right? So if you've got the right one that you need, you can turn it on and off there, right? I'll clear that one. I don't want that anymore. So now when I hit my zoom 9, then it just gives me the one I was working on, okay? So this has a negative correlation. Okay. All right, not real good because now when I find the best fit line, so stat over to calc, number 4, all right, and I'm using 5 and 6 now. All right, put it in y1, so alpha trace to get our y1. All right. All right, so let's write down our equation. And we can see that this correlation in this case is negative 0.7. All right, so even farther away from negative 1. So, and according to our graph, I mean, if we look at it, the points don't fit right closely to the line. Okay, the closer these points are to the line, the closer that's going to be to positive 1 or negative 1, depending on the slope and the correlation. Okay, all right, so here's our equation. All right, so we've got y equals negative 0.346x plus 106.4. Okay, there's the equation of the line. All right, but they want us to answer this question. Predict the temperature when the rainfall is 86 millimeters. All right, predict the rainfall when it's 86 millimeters. Well, let's see, rainfall is our y value, right? All right, so we need to find out when y is 86. Now I can do that a couple ways. I could solve this equation okay. I could solve that equation, but I'm not going to do that. I have I can utilize my calculator. So if I go back to my graph then, get to the line, all right, so, trace. So I go trace and get on the line. So it says I'm on the line here, okay, not the plot, but on the line. And I can just trace until I'm at, close I can get to 88, all right? So when x is 53, y is 88, all right? So my answer to this question then is come on. Missed that part. X equals 53, y equals 88. All right. So it says predict the temperature. So when the rainfall, how about 86 instead of 88, right? All right, let's go to 86. Sorry. All right, that's it right there. 59. So when the rainfall is 86 millimeters, the temperature is 59 degrees. Fahrenheit. Okay. So, how accurate do you think your prediction is? Okay, it's probably a decent accuracy because our line is a decent fit. Okay, negative 0.7 is okay. Now, if we're in the 0.5s or less, okay, the closer we get to 0, the worse fit it is. Okay, the closer we are to 1 or negative 1, the better the fit is. So this isn't a bad fit. Okay, be pretty decent. All right.